Hi, my name is Nick Pashis, and this is my optimization project proposal. So for my project, I chose to look at daily fantasy sports leagues, which have become a multi-billion-dollar industry. And in fantasy sports leagues, players choose teams of real-life players, and they compete against teams that other players have made. And each team earns points based on the actual performance that the player has in real life. And cash prizes are awarded to a certain top percentage of teams. So the challenge with choosing an optimal team can actually be modeled as a knapsack problem. And there are a lot of parallels here. But the challenge is to choose the best team within the cost constraints and a few other constraints. So for this example, the objects would be athletes, the weight would be their salary, and the value would be projected points. One constraint is salary cannot exceed a certain limit, and you also must select players to fill certain positions and cannot exceed a certain number of players in each position. Now, obviously, picking the best team based off projected points is not a guarantee for winning because player performance is stochastic. So instead of optimizing something based off projected points, we also need to optimize it based off the probability of winning. Now we can do this with mean variance optimization. And essentially, this method of optimization is about finding the right balance between maximizing projected score as well as minimizing the variance. So for my project, I will be using MATLAB to create two optimization methods, and I will be focusing on the 2018-2019 NHL season. NHL is actually a good sport to do this with because there's less variance as compared to other sports. I will be making one optimization method that is optimized for choosing a team based on max projected points, and then I will also be making one that is based on maximizing the probability of winning. I will also be running my simulations with historical data so as not to wait, each week to get actual player performance.